Hello, this is Erin Mizak, and I will be presenting about the real estate dataset. To answer my 3 questions, I will begin with my abstraction. An abstraction is the process of turning real-world entities and phenomena into data. In this project, I have abstracted a list of building into a list of reports, and each of these reports have a number of properties relevant to my project. The state and city are string properties that represent a section of the United States where some kind of buildings are located, which is needed to filter the data for what part of the country or state we are interested in looking at. The owned or leased is a string property that represents a determination of the type of property and whether that property is owned by a single entity or a rental agency that leases it. This information is useful to filter the data you are looking for, whether it is only owned or only leased buildings. The ANSI usable is a string property that represents the usable square footage in a building for people with disabilities, which is necessary to separate that from total square footage and how they differentiate. The parking spaces is a string property that represents the number of parking spaces that are allocated to each building, which is useful when filtering out minimum or maximum spaces needed. One of the best ways to understand the dataset is to look at its structure. The entire dataset is organized as a list of dictionaries, and each of those dictionaries has some number of dictionaries inside of them. The parking spaces key, which is a string value, is in the dictionary associated with the data key. I use this key in my project. There are quite a few limitations within my project. First, the date property is done by month, day, and then year. However, if it was only done by year, it would be more useful for comparisons and it could be used as a time value. Next, this dataset includes only string values. If it included other types of properties, such as integers, then it would be more beneficial to analyze the dataset. Another limitation is, this dataset includes ANSI usable square footage, but it does not include the total square footages of each building. Having the total square footage would be more beneficial to compare with the usable square footage. Lastly, this dataset contains a few mistakes as well, which hurts the understanding of the dataset as a whole. Some of those mistakes are spelling mistakes, string values that should be integers, and just an overall lacking of the real estate background information needed. My first question for this project is, what is the distribution of parking spaces for each building in Washington, D.C.? We all know that if you've ever been to D.C., that parking there or in any city in general is hard to find and or expensive. However, there are certain zoning regulations for parking. They are different for commercial and residential areas, but nonetheless they are required. Being knowledgeable on the parking requirements can make a lot of people's lives easier when followed and done correctly. This information can be especially important to any builder, commercial office owners, or homeowners in D.C. when establishing or fighting for those spots. For my visualization, I used a histogram to show the distribution of parking spaces in Washington, D.C. From this visualization, we can conclude that in D.C., buildings tend to have small amounts of parking spaces, as seen on the visualization, which can be expected in that area of the country. There are a few instances where they have above average amounts of parking, but overall the majority has very few. Limits on space in general, in turn, leads to fewer and more expensive parking areas in Washington, D.C. My second question is, what is the comparison of owned and leased buildings in a few of the Mid-Atlantic states? An article from Laura Casisto in the Wall Street Journal says how more and more people in the United States are now renting instead of buying houses. This could very likely change the future for developer decisions and the amount of properties they will turn over to rental agencies, rather than building neighborhoods where residents must purchase the house. For my visualization, I used one bar chart to compare the number of leased versus owned buildings in each of the 3 states. As you can see on my visualization, the 3 states I compared were Virginia, Pennsylvania, and Maryland, which I referred to as the Mid-Atlantic states. From the bar chart, we can see that for all 3 states, the amount of buildings leased is greater than the amount of buildings owned. Although these states do not have all the same amount of buildings being compared, it still gives you an overview of this upcoming trend in the United States. After looking at the visualization, I can better answer my question from before. The comparison of owned and leased buildings in these 3 states all point to notions that more people are indeed leasing buildings rather than purchasing them. My third question for this project is, what is the distribution of ANSI usable square footage in Boston and Seattle? In an article by John Morris from Wheelchair Travel, he lists the top 5 most wheelchair accessible cities in the U.S., which the top 2 are Seattle and Boston respectively. ADA requirements are established in new building codes. However, some of these regulations are different for previously built buildings. These cities mentioned seem to have fully updated the area and made it ADA friendly, which every city should be doing. This can also be helpful when building or remodeling buildings and ensuring you're making everyone comfortable that comes in, especially for businesses, and creating those disability-friendly workplaces. This will also help improve the usable square footage of buildings available to those with disabilities. For my visualizations, I used multiple histograms to show the distribution of ANSI usable square footage in Boston and Seattle. The visualization on the left shows the frequency of ANSI usable square footages in Boston, and the visualization on the right shows the frequency of ANSI usable square footages in Seattle. Both locations tend to have the majority of the buildings with lower amounts of ANSI usable square footage. However, they do both have a good amount with middle to high amounts of usable square footage as well. The x-axis is the same between the two visualizations, however the y-axis is different between the two, indicating that Seattle seems to have a larger amount of buildings overall. So to answer my question previously, both Boston and Seattle seem to have a decent amount of buildings with ANSI usable square footage, which in turn leads to more disability-friendly cities. Finally, let's look at the social impacts. These stakeholders would be interested in the results. Developers may want to know this information when planning to build, where to build, and what to expect in the market. Real estate agents would be interested in this information when trying to sell houses. It would also be important to know about the owned and leased houses in their area. Potential or current residents would be interested in this information when trying to make decisions of where to live, what the area has to offer, and whether to rent or buy a home. Corporate companies may also be interested in some of this info when looking for areas to establish companies and find offices. There will also be some potential conflicts. Real estate agents may end up getting upset with developers if those developers are catering more toward rental buildings, such as apartments or townhomes, instead of neighborhoods where houses are more likely purchased, which in turn takes away business from those real estate agents. Another conflict could be between the potential or current residents and developers. Those residents may not like what these developers' plans are and what they would be building and how it would change the town they live in. Thanks for watching.